Number talk's really a really easy thing to implement in your classroom.
7, 8, 9.
We were learning together. They can learn from each other. They can learn from themselves.
Both of those are the same.
They are.
If you're not sure, you can ask her to repeat it. You're sitting nicely. Maxwell.
She thought 3 and 4 was 8, but then she saw the 3 and she took 1 away and she found out that it was 7 and she added 2 more and then it was 9.
So, Imogene, did that sound right? Did you think 3 and 4 was 8?
Yeah.
Did you think this and this number and this number?
No, I knew
Okay,
that
explain it to Maxwell. What did you use and then you went back? Explain it.
I knew that I knew that a 4 and a 4 was 8, but I saw it's not a 4, it's a 3. So then I knew it was 1 down, and so then I counted 7 and then I counted 2 more.
Okay, so now can you repeat it?
She knew 4 plus 4 was 8, and she saw it was a 3, not a 4, and she took 1 away, and she knew it was 7, and she added 2. She put 2 more, and it was 9.
Ask her if that sounds like how she solved it.
Is that how you solved it? Yes.
Give them a 2-finger clap for sharing.
Children are capable of reasoning about numbers.
It'd really be the same problem, only whichever one is easier, I'd do.
They may think of something in a way that you've never thought of before.
Then the 60 would become 59 again.
Your answer would be right here.
Present them with a problem.
So my question is, if I go to the East Palo Alto Library and the Redwood City Library, what would be the total number of books we would have about planets? Think. We have been teaching them strategies to break apart and put together numbers in their head. And it involves a lot of academic discourse, and the students are able to use the vocabulary we teach them to explain their process. First to their partners. Knee to knee, eyes to eyes. I'd like partner A to start.
I got 90. I used decomposing. I broke 60 to 60 and 5. I used 60 jumps of 10. 60
The 3 strategies we've learned so far are decomposing.
I used decomposing. I broke 65 into 60 and 5. I broke 25 into 20 and 5.
This is breaking numbers out into their expanded form.
And the 20, and I got 80. I added the 5 to the 5, and I got 10. I connected the 10 to the 80, and I got 90.
Show if you agree. Somebody solve it with another strategy, another mental math strategy. Carlos?
I got 90. I used split it. I split 65 to 50 and 15. I added the 50 to the
The next one is splitting, breaking numbers apart for any number of reasons. Some reasons might be to create doubles. It might be counting 25s, quarters, whatever might make sense.
That equal 90.
Between decomposing and splitting, why are they different? Lisette?
Because when you decompose, the tens had to have a 0.
So good, she's got us started in the right direction. So when you decompose, you're breaking into the
60.
tens Esteban?
That in decomposing it's expanded form, and in splitting it's not.
Who else was remembering its expanded form? We're breaking up tens and ones. Splitting? This isn't 45, so that's not splitting into the tens and the ones. You can split any way you want for lots of different reasons. And then the third strategy is jumps of 10.
I took a jump of 10.
You did jumps of 10? Okay, let's count your jumps. Ready? 1. Basically picturing a number line and hopping up tens and then adding on whatever's left from the ones place at the end. The students are allowed to choose favorite strategies where it just maybe works for their brain better, and they realize that they are a vital part of the process. Without their brain, the learning can't happen.
Look at our strategies and decide if they work or if we need to revise them a little bit. So I want to start with Alex's group and I heard a lot of groups actually talking about number 4. Number 4 came up a lot of how you could break a rectangular prism into layers and add up the amount in each layer. So Alex's group, can you start by telling us what you thought about that? And I would have Alex speak first, please.
I think you should break it into different layers. Like this is 12, and you should multiply it times how many, like the layers, like one layer times all the other layers, which in this case would be 12 times 5.
Okay, can I have another student repeat what Alex said? How would he maybe revise strategy number 4? Shamari, go for it.
You count one layer and then you multiply it times how many other layers you have.
Okay, Alex, is that the strategy you meant?
Yeah.
150 and 150 and then 10. Oh, I get what she's saying.
One of the reasons I love doing number talks is because I just love hearing what the kids have to say.
Instead of 2 times 15 times 6, it's 2 times 6, which is 12.
Awesome thinking, awesome thinking. A few weeks ago, I was talking to a friend, a colleague, about teaching math. And we both agreed that we have walked through a door and we will not walk back the other way.